Let me record this. So yesterday my intention was, while explaining the collection on this, we will be talking about list interface, we'll be talking about set interface, and we'll be talking about map interface. Actually, the map interface is not part of your collection interface. I mean, it is not extended collection interface. Your map interface is different interface. It has its own classes. It's a separate interface. So from the collection, there is one more interface called queue. So we don't need to talk about much here. So we'll be talking about list, set, and map. List, set, and map. Clear? Map is separate interface. Map is not implemented. Map is also part of the collection framework, but map is not implemented collection interface. Collection is a different. Collection is a general terminology saying that group of things. Collection is, there is another called collection is interface. This is an interface. This is an interface. This interface is implemented by the different classes. That is different. That's I'm trying to say. Clear? Okay, let me recap one more time what we have discussed yesterday. We have discussed yesterday something called collection. Collection. What is a collection? Collection is a collection of group of a collection of or a group of objects or objects where we can perform set of operations. Where we can perform set of operations. Sir, what are the operations we will perform, sir? We will perform the operations are like, searching for an object, modifying an object, inserting an object, sorting an object, deleting. So this kind of operations we will do on a set of objects. That operations where who is providing that options to you, who is giving you option to do all these operations, that is called collection framework. That is called collection framework. So collection framework is something called, it is giving you to do some set of operations on set of groups. That is called collection framework. Framework means which is a predefined libraries will be there, a predefined which comes a boiled I mean what to say, boiled code of plate will be there, where you need to do, just extends or just make use of them for respective scenarios or respective requirement, right? So the collection is a group of objects. Collections, there is something called collections. That is an interface. The interface has been implemented by list interface. Actually, they're extended. Okay, they're not implemented. List interface extended collection interface. Set interface extended collection interface. Queue interface, there is something called queue interface, that also extended collection interface. These interfaces again implemented by the different classes. We will talk about them one on one. Is that clear? So I may yesterday I have said map, no, map is not part of here. So my intention was something different, but I didn't observe when I was explaining it. But when I was going through the recorded sessions, I found it is something wrong I explained. Is this clear till here? Right? So the collection saying that collect the different things and make it as a single unit. So that is called your collection framework. Any doubt? Anisha?
No, Veera, it's clear.
Right? So let's see the actual architecture, how the architecture will look for the hierarchy. Instead of saying architecture, let's see hierarchy of your collection framework. Okay, the hierarchy or the architecture of the collection framework is, we know that there is something called object class. We know everyone object class is the parent class, correct? This is your parent class, and in this you have something called iterable. There is something called iterable interface. there is something called iterable interface. There is something called iterable. Anyway, it is by default. It's a object is a parent of everyone. Object is a parent of everyone, right? And from here, there is something called collection interface. There is something called collection interface. There is something called collection interface. This collection interface has extended because interface can extend interface. Yes or no? An interface can extend interface. Yes or no? Sai, can I extend an interface from another interface? Vaishnavi, Anisha, Aparna, can I extend the interface?
Yes, Veera.
One,
We can extend.
one interface can extend any number of interfaces. If you remember, we discussed about this, right? Interface 1 extend interface 2, interface 3, interface 4. It can extend any number of interfaces. So the collection interface has been extended. So guys, whenever you see the thick line like this in the class diagrams, it is extends. Whenever you see dotted like this, implements. That's the only difference. Okay. Now this collection interface has been extended by a set of interfaces that is called list, that is called set, that is called map. Sorry, queue. I'm writing queue here, but I'm telling map queue. So here these interfaces has been extended by this collection interface has been extended by three different classes. Interfaces. So each interface has been implemented by set of classes. Each interface has been implemented by set of interfaces based on their behavior. Based on their behavior. Let's say the list has array list. It has vector. It has a linked list. Linked list. It has linked list. And set also did the same. Set also has been implemented by a set of classes. Has set, linked has set, tree set. These are also has been implemented by these three classes. And queue is there, some priority queue, doubly linked queue, and all no things. We're not going to worry much about it. Along with this, which is not part of collection interface, it means there is one more interface, but it is not extended your collection interface, which is not extended your collection interface. That is called map. That is called map interface. This map interface has been implemented by different classes. What are they? Hash map, hash table. There is something called linked hash map. There is something called tree map. Okay, these are all. This is the I can say hierarchy, or I can say architecture of the collection framework. Collection framework, right? So let's go ahead and look at how we can write our collections code. I mean, how we can create a collection objects. Okay, how we can play with the multiple objects, right? Your, as I said, your collection interface has some set of methods. Interfaces contain some set of methods, right? Which needs to be implemented by the downline, the implemented class, right? So which needs to be implemented by the implemented class. Let me open this my Eclipse. To best way to see what are the classes are implemented by collection interface, if you guys remember, I have given you Java document, Java 7 document. It's 7 or 8. Now it's a 10 also is available. So let's go to specific documentation. Yeah, this is they changed it. In the before it was documentation. With frames. Now look at here. This is the documentation I'm talking about. So here in the first frame you'll be having something called packages. The second frame you'll be having all the classes from the respective package, and here you'll be having a description about on each what are the class you selected. Let's say I'm going to select a collection package, collection framework. The collection framework comes with a package called util package, util java dot util package. Util package means utilities, right? Playing with your data. So when I select the collection package here, which is called util package, the respective interfaces and classes will be listed out here. Respective respective classes, interfaces, enums, all will be whatever is available in the that respective things. Respect to package, util is nothing but a Java is one folder. In that util is one folder. In that folder, these many interfaces are there, these many classes are there, these many enums are there, these many no the exception classes are there. Okay, so all will be listed out here, all will be listed out here in this. Look at guys here. Now we're talking about collection interface. We're talking about collection interface. Okay, if you see this collection interface, the super interface is iterable. His parent is iterable, right? And sub interfaces who are all extended this collection interface, So you have something called blocking queue. These are all different interfaces. We'll see about them later. So the DQ, so which we're not going to discuss as part of this. List interface, set interface, listen set interface. These are the major we are going to discuss. There are some sorted set. There are something called transfer queue, DQ, just queue. So there are some other interfaces. Okay, and if this is something about what is the interface, what is the collection interface. The notes about I can say description about your collection interface. Okay, in this, if you see, there are some methods. There are some methods in your collection interface. If you see all the interfaces here, add method, which you can add an element, there is another method called add all, adding a couple of or collection of elements into a specific group. Okay, so add is you are going to add a new element to a specific group. The specific group can be your array list or your vector or whatever it is. Okay, clear, removing all. Contains, you're checking whether it exists or not. Contains all, you are checking group of people or group of objects are existing in the group of this other set, superset of objects. Equal, hash code is empty, iterator, we'll talk about the iterator because it's required. And parallel stream, not sure what it will really do. So remove all, and retain size. There are some set of methods are available in your collection class interface, correct? In the collection interface, there are set of interfaces are there, methods are there. These methods has to be implemented by your implemented classes, right? Let's look at that. So if you want to see is there instance methods, you want to see is there abstract methods, you want to see is there default methods, right? So you can see all of them. So default method, there is something, it comes in Java 8. So we are seeing we are seeing something is Java 8 doc. We are seeing something is which is a Java 8 doc. If you see Java 7 doc, you won't be having that. If you're seeing a Java 7 doc, util, go to util, go to collection, we have methods. You do not have anything called default methods or something. In the Java 8, they have, anyway, all are abstract methods. You don't need to specifically say that. All interfaces, whatever the methods are there in interface, by default, they are abstract, right? So here, see, these are the methods, the same methods. And there in the Java 8, there are some more methods has been added. Those are default methods like a streaming, parallelism, split iterator, splitter, stream. These are some default methods has been added. I really not sure what they are. Okay, so this is other methods. You can have a look. Okay, so what is each method will do, as discussed high level, you can find the size, you can find the whether it is empty or not, you can check whether is there any contains. So you can iterate through. Iterate means iterating, going through each and every object. Okay, iterating through each and every object, that is called iteration, that is called iterating, right? So we need to talk a little about iterator interface. Let's talk about iterator interface, which is needs to discuss as part of the collection. We will talk about this iterator interface. What is iterator interface? The iterator interface is meant for traversing through or going through each and every object in the collection of objects, going through into each and every object into each and every object into collection of objects, right? It has something called has next method, he has something called next method, he has something called remove method. What is that? Let's assume that I have array. Let's assume that I have an array list. Instead of saying array list, now I want to traverse from here to here from this object. I want to retrieve one after one. I want to traverse from here to here. I want to traverse from here to one. So I want to traverse. I want to iterate. So I have a method called has next. What it will tell, is there any next element? The first method is has next. It will tell that is there, I'll be in the very first position. Initially I'll be in a very first position. So when I'm representing this position, I need to go to next. Okay, let's say I want to go to next. Before going there, I will check whether it is there or not. That is called has next. It will return true if it is exist. It will return false if it is not. Then if it is true, then you can move by using next method. You can move by using next method. While you are moving next method, while you are moving from here to here, what it will do, it will return this object, return the object, whoever called the next method. From there it will return to him the object, then it will move to next position, then it will check is there any next position, yes it is there, then move. So it means as soon as you execute the next method, it will return the respective whatever the object I am, that object will be returned, right? Let's say now I am in array list. Let's say array list or list, I am in this group of objects. Now I'm at the first position. Now I want in the first position. I need to traverse through whole this array. Now what I will do, let's assume that this is ARR. So let's assume that I have created iterator. I have created iterator on this list. Okay, now what I will do, iterate dot has next. As soon as I do this, what will happen? It will check, is there any element in the next position? Next position. If it is there, it is actually will go into the condition, guys. Okay, if condition, or if you want to do while condition, we'll keep it sometime. Most of the time, we'll keep in while condition because we need to check whether it is there or not. If it is there, then go ahead, take object equal to o equal to it dot next. As soon as you say iterator dot next, this next method will return the object of the first object to this variable. This is how the iterator works. And there is some method in that remove. While you're iterating, you can remove the element also. While iterating, you can remove the element also. Okay. So we will see all this thing in very detail. So not to worry. We'll talk each and everything, very detailed. So everyone is understand what is iterator and what is the collection interface? Any doubt? Guys, any doubt? Aparna, Anisha, Vaishnavi, Kishore, Ganesh,
No, sir.
clear, right? So let's talk about something called list interface. Now we need to talk about list interface. We are saying the first interface what we are going to discuss about list interface. So we have seen yesterday some features of the list interface. Let's talk about the same list interface a little detail here. So this is Java 7, right? So you can find the interface here, list interface. What is a list interface? List interface is a collection of objects which will allow to collect the group of objects. It is ordered collection, guys. What is the order? What is that order? Insertion order. As I said yesterday, the list interface is an interface. It has a set of behaviors. It has some set of behaviors or functionalities, we can say. Those functionalities are, it will maintain the index. Let me write here. Let me write here. List interface. The very first one maintains index. Maintain index. It has index. Your list interface, who the first feature of the first functionality of your list is, or first feature of the list is, it has an index. It has index. Second one is maintains the insertion order. Maintain insertion order. Insertion order. Whatever the order you have inserted, it will maintain the same order. Third one is it allows the duplicate, guys. Allows duplicate. It allows the duplicate. Let's assume that you want a group of objects which needs to allow the duplicates as well. It need to have a duplicates as well. We will go with the list interface. We will go with the list interface. And the fourth one is allows the null. Allows the nulls. And dynamically grows. dynamically grows. These are the features of your list interface. These are the features of list interface. Anyway, the list interface is extending the collection interface, correct? So it also gets some of the methods from your collection interface. Anyway, it's all the methods whatever then parent class, parent interface here. The same methods I can access in my child, right? Yes or no, guys? Whatever the methods are there in my parent interface, same methods will be available with the list child interface as well, right? Again, the same add, you have something called, you can add it, and there is something called add index, means you can specify which position you want to add. You can specify your adding is always, it will add in the bottom. Okay, add, this add is like you can add into specific position. You can add into specific position. I want to always add into the second position. You can go ahead and specify add second an element, and then the elements will be adjusted. It not override the existing element, guys, because it's a dynamically growing array, right? It is not array list. If it is array, if you specify, if it is array, if it is array, let's assume that I already have a b here. So if I say here x, what will happen? This b will be overridden with x, because it cannot change that, it cannot adjust the positions, it cannot adjust the positions because it will not automatically grow, right? But when it comes to array list, when you say, when you try to array list, when you specify the position like this, add of second position or second index, it's not like it should be one here. So second position, I'm saying z. So what does it mean? In the second position you want to assign the z. So what will go here? Here you want to say z. Now what will happen? The c will move to the third position. The C will move to the third position. The Z will be here. It's not override existing one. So try to remember, guys. This is the called dynamically growing array. If it is array, if it is a normal array, it could have been fail. Saying that, I mean, it will not fail actually. It will override, right? Because it will not dynamically grow. The size is fixed in the arrays. Correct? Correct? Yes or no, guys? Right? So at the same way, you have one more method called add all. Yep. So there is one more method called add all. What it will do, let's assume that I have this array list, a list, a group of objects. It's a group one. Let's say it's a group one. I have another group two. I need to add the group one into group two. It should allow me to add all the elements at a time, no? Right? That is called add all method. That is called add all method. You can specify add all method blindly. It will add at the bottom of the existing list. And you can also specify the position. You can also specify the position. Clear, removing all the elements. Contains, checking whether it's there or not. Contains all. You have a superset and you have a subset, and you want to check is the subset is exist in the superset or not. Contains all. Equals, you guys know what is equals method. Get, this is important, we need to understand, which is belong to a list. Get, get is the method where you want to fetch a specific element. Let's say now I want to get from array. You have something like, suppose you want to print element of second position. What you will do? You will specify like this, correct? But in the collections we don't have like that. We have collections, we're playing with an objects, right? Here something like, see here, array is not an object. First thing, array is not an object. It's a linear list of elements, and which has the same data type. It will be referring, this is a variable, right? It is a variable. But whatever we are going to create, whether array list, if you see yesterday's example, array list, this is an object. The al is nothing but an object, right? So you cannot say al of second position. You cannot say like that. You have to access a method in it, al dot get off second position. When you say al dot get off second position, you will fetch the element from that object. I mean, from that collection of object, it will bring you the second, second position object. From, it will start from the 0 0 1 2. Okay. So anyway, we will be seeing those methods, guys. But here I'm explaining you very high level because you will get a little taste before before tasting actual thing, before eating the things, right? Clear, you know, color contains all equals get hash code. You guys know index of is empty iterator. It's a method to iterate through your collection. Last index, right? remove remove object, remove specific position. You can specify remove from the second position. You don't know the position but you want to remove specific object. You don't like to have a C in your other collection, so you remove the C. Remove all specific collection. Okay. Retain all. What is the retain, guys? What is the retain? Returns the only element in the list which are that are contained in this. Suppose I have a collection and I'm going with another collection. Whatever the variables are matching, those only will be returned to you, like intersection, the common elements. You can have something called set. You can have something called set. Sir, you have told me. So when I do add by specifying the position, it is moving the position. So is there something called I want to override existing one? Yes. There is some method called set method. What the set method will do, it will override, it will replaces the existing element. Okay, it will not move the elements, it will just override the existing element. Size, you can get the size of it. You can create a sublist on it. You can create a sublist. You know what is a toString method? I think toString of it is generic type method. So I think you guys know it, right? These are the methods are available with the list interface. And what are the features of the list interface? It will maintain the index, it will maintain the odd insertion order, and it allows the duplicates, it also allows the null values, and it also dynamically grows. So what is the proof, sir, it has the index or not? If you see most of the methods here, all are having index. Clear guys? Okay, so let's see a first class which is implemented list interface. We will talk about a class which is implemented list interface. The class is ArrayList. Talk about ArrayList. What is ArrayList, guys? We have discussed yesterday about ArrayList. Can someone tell me what is ArrayList? Can someone tell me what is ArrayList? We have discussed yesterday.
It's a dynamic array list of arrays.
Okay.
It is indexed
Mm-hmm.
and allow duplicates.
Mm-hmm.
It allows null value and it's ordered
Mm-hmm.
and allows random access.
Okay. Yes. So ArrayList, very good, Aparna. ArrayList is backed by, it means ArrayList internally uses the array only, but what type of array? It's a dynamically growing array. It's a dynamically growing array, and all the features, what are the features we have seen the list, the same features will come in ArrayList as well. So it will allow the duplicates, it will maintain the insertion order, right? It is it has the what to say, index, it allows the null values, it grows dynamically, and along with them, because it's a class, the whatever the methods are there in the array list are not synchronized. So we talked a little about the synchronized sometime before. What is the synchronized? What is the synchronization? Can someone tell me? Okay, so please tell me please go through what is the synchronization. We already discussed about the synchronization, and let's I mean, you guys can have a look on that. So other one is ArrayList is good. ArrayList is the best for random access. ArrayList is best for accessing. ArrayList is good for accessing because internally it uses indexed base access, and it's implemented random access interface. It is implemented random access interface. Let's look at guys here. So now I have selected utility package in that list interface, right? After list interface there is a class, right? What is that class? ArrayList class. Look at ArrayList class. Look at here, ArrayList ArrayList class. Okay, and it is what are the interfaces is implemented. Serializable. You guys know what is a serializable. Clonable. What is a clonable? Iterable. Iterable is anyway it's a parent. Iterable is anyway it's a parent, right? Iterable. And collection. Anyway collection also parent. List. List also parent. Your ArrayList class I'm talking about. These are the interfaces implemented. Random access. There is something called random access. The random access is a marker interface which does not have any methods, but it will enable a specific feature to the specific class, which is ArrayList. What is the specific feature? The ArrayList class has a feature of um, accessing the elements randomly. It will enable to the JVM, it will tell to the JVM saying that whoever writes the ArrayList class, they have a feature like they can access randomly. That feature will be enabled to JVM. That's the purpose of the marker interface. That's the purpose of your marker interface. Is that clear, guys? If you want to know more about random access, you can click on this. You can go, you can check what is a random interface or random access interface. Okay, so those are the features of it. Then what is the limitations of ArrayList? The limitation of ArrayList is it is not good for it's not good for well suited or good for more insertions, deletions, something called manipulations. Something called manipulations. Why? Not good in the sense can't I do them? You can do them. You can do them. But your ArrayList will be very slow while doing that. The reason we already discussed yesterday. What is the reason? When I'm inserting the elements, insert, I'm not talking about set, I'm talking about insert. Okay, setting, there is something called set. Just now we have seen set method. I'm not talking about a set method. This is my array list, not array, it is array list. In this I have some elements. A, B, C, D, E, F, G, H, I. I'm just taking sequentially. Okay, now what is the positions of these elements, guys? 0, 1, 2, 3, 4, 5, 6, 7, 8. Now all of a sudden what I did here, al dot add of k. What will happen? It will get added here, no problem, fine. When I say al dot add of 5 comma M. Now what will happen in this case? What will happen in this case, guys? Look at here. Look at here. Go back to our ArrayList class. What is the method I have used? I have used this method. Second method. I have used this method, correct? Second method. Click on that. Go here. Inserts the specified element at the specified position in the list. Shifts the elements currently at that position, and any subsequent elements to be to the right hand side will be moved. What is happening as soon as I did that operation? The elements as soon as I did this, I want to put in the fifth position. As soon as I did this, all this will be moved. Here M will come, F will go here, G will go here, H will go here, I will go here, K will go here. It means you are shifting the positions. Yes or no, guys? Which is a time consuming process. That's why it is slow. Let's assume that I deleted the same. You have the command, right? You have the method, right, to delete, remove. Look at here. Remove specific position. What will happen? Remove the element at the position at the specified position in the list, shifts any subsequent elements to the left. Suppose if you remove a position, all will be moved to left side. So it means if I remove this element from the fifth position, all will be shifted. This will go here, this will go here. To reduce the size of array, right? So it will move here, it will move here. So what's happening? For your insertions, for your deletions, ArrayList is not best suit. It doesn't mean that it will not allow. It will allow, but it is not a best suit. Are you guys clear about the ArrayList? Are you guys clear about the ArrayList?
Yes.
Yes, we do.
Yeah. So let's see ArrayList class. Okay. I'm taking. Let me save this in somewhere. Let me save this somewhere by creating this. And this is now. So we're talking about ArrayList. Look at the ArrayList. ArrayList comes with three different constructors. Three different constructors. What are they? What are they? ArrayList, a default constructor or empty constructor. ArrayList with the collection of, you can pass another collection into that. ArrayList with a capacity. Right? With a capacity. Construct an empty list with a specified initial capacity. How much can initially keep? After that certain threshold reaches, after that when I reach the capacity, I need to double the size or I need to increase the size. That capacity you can specify. Understand, guys? Okay, let's look at these constructors. So let's look at these constructors, how the constructors will be created. Let's look at here. I'm going to create some array list al equal to new array list of blank. I'm creating one more array list. Array list al2 new array list of You can pass another array list here. You can pass another collection. Not only array list, you can pass another. But by time being, I'm passing here AL. Let's assume that here you have some AL, you have added some elements. Let's assume that you have added some elements here. AL dot add X, AL dot add A. Let's assume that you have added some elements. Since it means in your AL collection you have two elements. In AL collection you have one is X, one is A. So now you want to add into this AL2. Now as soon as you did this, your AL2 has already two elements. X comma A, because while creating itself you are passed. Then if you say AL2 dot add B, the B will be added here. One second guys, please be online. I'm just getting call. So once we understand the basic of array list, or once you understand the basic how we'll write the collections, how will we create the collections, and the rest of the collections like a set interface or map interface, it will make your life easy to understand, right? So that's why I'm spending more time on the initial part or collection part, or explaining the collection multiple times, explaining the arrays multiple times, because if you understand this, it will be like a base to understand your collection framework. Okay, so it will help you to understand the other part, like going forward, the set interface, map interface. If you want to go through yourself with the queue interface, it will make you easily understand, right? That's the reason. Yep. So any doubts, guys? We will see a program tomorrow, we'll execute it. It's very simple. So you can just go and add, you can see whatever the methods we have seen here, right? We will implement all the methods, nothing else. So we will try to add element, we will try to add element with a specified position, we'll try to add element of collection of elements, we'll try to add in a specific, like this we will be applying these methods in that collection, in that class. Okay, that will be a simple example. That will not be a complicated or complex example. Okay, any doubts, guys? Any doubts? Okay, so thank you guys. We will be seeing tomorrow, and we will be executing an example, and we will complete the array list, and we'll try to complete a complete list package tomorrow. List, if it's possible, set package as well. We'll try to complete tomorrow. Yep. Any doubts? Anisha, Ganesh, Kishore, Masood.
No, Vera.
Yep.
And have you uploaded the yesterday video, Vera?
Yesterday video I didn't upload.